This is a video about topic 2, materials from Earth, in CE1 Edexcel Physics, Edexcel Chemistry. Talks mainly about rocks, limestones, and a bit about balancing equations and atoms and chemical reactions. So let's start with rocks. Before I get into rocks, there's always questions on this area, mainly about rocks and limestone. So certainly make sure you can do this. And when we get onto balancing equations, it's something that you're going to watch videos on YouTube about and spend a bit of time making sure you can do that. So there are 3 types of rocks: igneous, sedimentary, and metamorphic. You need to be able to give examples of each and explain how they are formed. Okay, so igneous, the main example of that is granite. That's the one that most people go to straight away. There's 2 types of igneous rock. There's what we call extrusive and what we call intrusive. Extrusive, okay, they're going to cool down slowly. Extrusive are going to cool down quickly. Okay, so they can have small crystals. Okay, they just cool down outside the volcano. Intrusive cooled slowly. So intrusive cooled inside, so they're cooling down slowly. Therefore, they have large crystals. Okay, so this is when magma or lava from volcanoes solidify. Sedimentary rocks, okay, they are made up of layers of sediment and they're compacted over a long period of time. So sediment is like broken bits of rock over a long period of time, get compacted together. They may contain fossils. Okay, not always, but they may contain fossils. But if you see a fossil, the rock's definitely sedimentary. They can be eroded easily. The main examples of these are like chalk and limestone. Metamorphic rocks, they're formed when heat and pressure are applied to a rock. Marble is formed from chalk or limestone. When heat and pressure are applied, that's what you get. Marble. The grains are weakly joined with gaps in between them, so that heat and pressure allows these grains to make new crystals and therefore become tightly interlocked. Okay, and that's how you get a harder rock than you would have had before. So like calcium carbonate becoming marble, you've got that harder rock than you had before. So if you ever ask about how metamorphic rocks are formed, you say by heat and pressure. Okay, so that idea of limestone becoming marble, that change happens because of heat and pressure. So chalk, limestone and marble are all natural forms of calcium carbonate, and they can be found in the Earth's crust. So that's where we get those from. We essentially quarry them. Okay, so limestone quarrying is one of the biggest things, biggest industries, because of the fact that it has so many uses. And the main uses are that we use it as a building material to make cement, to make concrete, to make glass. It's also in toothpaste, believe it or not. So calcium carbonate is a very, very useful material. To extract it, we need to quarry it. A quarry is like a big hole in the ground. So you need to know the advantages and disadvantages of this process. So the advantages are that the materials are required for everyday life, just like we listed above. They can be used, the reactions from limestone can neutralise acidic soil. They can also neutralise sulfur dioxide in power stations, that's preventing acid rain. Provide jobs to boost the local economy. It can also improve facilities such as like transport and roads and recreational facilities. So they might build a cinema in an area to try to get more people to live there because they want to give them a job at their limestone quarry. But the disadvantage is you've got this permanent scar in the landscape, and you're blasting rocks, which produces a lot of noise and a lot of dust in these like quite scenic areas. It does destroy the habitats, and those lorries are going to be using the transport links, so therefore there'll be lots of noise from the lorries and lots of traffic because of the lorries too. So when we have these rocks like calcium carbonate, i.e. limestone, okay, we can do a process called thermal decomposition. All carbonates, such as calcium carbonate, limestone, when heated, react in the same way. It can be any metal in this process. So I've done calcium, copper, zinc in this, but it can be any metal carbonate. So that should say limestone, so there is a small mistake there. That should limestone has a formula CaCO3. When it's heated, it thermally decomposes to make calcium oxide and calcium dioxide. Okay, let me just make that correction there. Sorry. Keep that. Good. Limestone. Yep. So it has a formula CaCO3. When it's heated, it makes calcium oxide and carbon dioxide. So here you go, CaCO3 heated up, CaO and CO2. If it's copper carbonate, same pattern. Zinc carbonate, same pattern. Okay, always zinc carbonate or copper carbonate. So I've got decomposes to zinc oxide or copper oxide and carbon dioxide. So some metal carbonates decompose faster than others, depends upon the stability of the metal carbonate. Less stable carbonates decompose faster. Occasionally a colour change will happen as well. and carbon dioxide is given off, and that can be detected by using lime water. So that's CaOH2. Lime water, remember, will turn cloudy from clear. Will turn lime water from clear to colourless to cloudy white. Okay, so that's what it does. It turns it from clear to cloudy white. Essentially, it makes it milky. So lime water will be turned milky in the presence of carbon dioxide. It's a key test that we could ask you. A key test for a chemical. When water is added to calcium oxide, calcium hydroxide is formed. Calcium hydroxide is used to create lime water. Okay, so that's how that links to that carbon dioxide process. So there you go. Calcium oxide plus H2O makes CaOH2, calcium hydroxide. Okay, so make sure that you also know how to balance equations. So the first thing to sort of link in with that is this idea over here. Atoms are the smallest particles that you can get for each element. During chemical reactions, atoms are not created or destroyed, just rearranged. The products of a reaction, what comes out, must have the same number as the reactant that went in. So that's what we talk about when we talk about balancing equations. But they're arranged in a different structure. This means they have different properties. This is important as well. The total mass before a reaction will equal the mass afterwards. So some of it might go off. So if you think about those carbonate reactions, that carbon dioxide leaves. You can't measure that mass anymore, it's turned into a gas. But if you could measure that mass and you added it to the mass of, say, copper oxide that remained, it would be the same as a copper carbonate that started. Okay, so when copper sulfate reacts with sodium hydroxide, copper hydroxide is formed along with sodium sulfate. The mass of copper sulfate and sodium hydroxide is equal to the mass of copper hydroxide and sodium sulfate. So just because the atoms are rearranged doesn't mean the mass has been lost, the mass is just rearranged as well. So the mass is the same on both sides. This happens as long as it's a closed system. Nothing is allowed to escape. If something is allowed to escape, it's usually CO2. It's usually a gas. As clear reactions take place, as copper hydroxide is a precipitate. It is insoluble. It doesn't dissolve in water. You learn more about that in C2. Remember that equations need to be balanced. They need to have the same number of atoms on each side of an equation. C2 has 2 carbon atoms, while 3C2 has 6 carbon atoms. 3NH3 has 3 nitrogens, but 9 atoms of hydrogen. Okay, so remember you need to make sure it's the same on both sides. When you're rearranging when you're balancing equations, you cannot put the number at the bottom here. That can't be done. You can only add the number in the front. So like this number here, that 3, you can't put a 2 in. So you might want to put 3 there because you want 6 carbons rather than just having 2. Okay. Also know your state symbols. Okay, so solid, liquid, gas. AQ is aqueous, which means it's dissolved in water. And that's the video for topic 2. Rocks. It's about rocks, thermal decomposition, and atoms and mass. So it's topic 2, materials from the earth of C1 Edexcel chemistry.